Okay, let's talk about everybody's favorite subject, heart disease. Let's jump straight into it. So I wanted to talk about this because of a simple reason. The number one cause of death in the United States and indeed in the first world is heart disease. So about, I think, a quarter of the people in the United States die due to heart disease, and a little bit less in second place is cancer. So really, if you think about it, if you're trying to not die, you should focus on these two things first. There's other things that could kill you, obviously. The world is not a wonderful place, but you should focus on these first. And in developing countries, this is not an issue, not because they're so healthy, but because they tend to die of other causes. So it's not a great thing. Basically, in developed countries, the heart disease is the number one cause of death. So what is heart disease? Well, in general, heart disease is a large umbrella of different things that can happen to your cardiovascular system and to your heart. And so a lot of people don't talk about the more rare things that can happen, like congenital diseases of the heart or certain rare freak accidents that can happen to heart valve disease or whatever. There's other stuff that can happen that's not your usual kind of classical heart disease thing. So we won't talk about those today, but just keep that in mind. There's a lot of diseases and problems that can happen that fall under the umbrella of heart disease. But the main one we're going to talk about today is basically hardening of the arteries, or atherosclerosis. Let's see if I can spell this in my new trackpad. Write it down. Still learning how to write on this thing. Atherosclerosis. Okay, so this is basically hardening of the arteries that could result in either a heart attack or stroke. Okay, so this is important to think about right now. So stroke, even though it happens in the brain, stroke is considered heart disease. Why? Because it's a result of a plaque that develops in the arteries that breaks off and forms a clot, and we'll talk about the process that causes this in a little bit. But a stroke is basically a clot that travels to the brain, and so when it travels to the brain, it's called a stroke, or an ischemic stroke, but we don't have to worry about that for now. So brain, when it affects the brain, we call that a stroke, and when it affects the heart, we call it a heart attack. But they're really the same thing. They're blockage of blood supply. And so the organ essentially dies, which is very serious if your organ is a heart or a brain. If your organ is your pinky finger or your small toe, that's not much of an issue. It's still a problem. It's not much, heart stroke, it's heart attack. It's not much of a problem if it's your pinky or some extremity like that, but if it's your brain or your heart, obviously it's important. So keep that in mind. Stroke is really heart disease. It's not a brain thing. Okay? All right. So if there's one thing that you can take away from this video, it's that it's impossible to simplify this problem. Okay? Heart disease is a complex process. It's precisely why people have been trying to simplify it, and you hear all these quack theories. Oh, this causes heart disease or that causes heart disease. Basically, any simple explanation for what causes heart disease is almost guaranteed to be wrong. Maybe at some point we'll find a simple explanation for it, but I doubt it. It's basically a complicated process that involves many different details. And so there is no one easy solution. And that's why really we haven't found a definitive cure for it. We have ways to manage the symptoms or lessen its severity or whatever, but we don't have a cure. It's not like having a bacterial infection. You can just take some penicillin and it goes away, because bacterial infection today, it's a simple thing. 300 years ago, we used to think it's caused by demons or something, whatever. But basically, it's a complex process. So that's important to think about. It's a complex process that usually takes decades to manifest, and that's why it usually affects older people. But not necessarily. But that's why, in general, older people are more susceptible to heart disease, or it's more common in older people. Okay, so here's the thing. There's basically two types of vessels in your body, and you probably already know this. You have arteries, and you also have veins. Now, your arteries are what sends blood out of your heart. So you can think of your heart as a pump. It sends blood out to tissue. So here's like the rest of the body, abstract body. Okay, and the body uses the nutrients and oxygen and whatever in the blood, and then returns the blood as veins, or in the veins, to the heart. That's really a simplified aspect to it. There's also a cycle that involves the lungs. I don't know how you draw lungs. This lungs, oh, I really butchered that one. Let's try again. Yeah, that's terrible. But yeah, this is your lungs. There's also a cycle that feeds, it's actually the other way around, that feeds the lungs, but you don't have to worry about that for now. But the main thing is that your arteries are the high pressure output of the heart, and the veins are what return the blood to your heart. Now, here's what's interesting. Heart disease almost universally, again, like I said in the beginning of the video, there are some exceptions, but universally affects the arteries only and not veins. And the reason for that will become clear in a little bit. But veins are not really involved in heart disease. And so usually when we say it clogs blood vessels, we're really talking about arteries only. And those are the ones that involve cholesterol and all that, plaque buildup and all these things that you hear about heart disease. Okay, so let's look at what makes an artery different from a vein. The main thing is that an artery is not just a tube. So this is bad because a lot of diagrams, etc., falsely make it seem like the artery is just a simple tube, like a PVC pipe or something, and that's not true. The artery actually consists of 3 layers, but we can just draw 2 for now. They're most interesting. So there's the media, and then there's the intima. Okay, let's try that again. So this layer over here, the inside wall, is called the intima. Intima. Again. Okay. So this piece over here, so this is the media in here. It's not the news media. It's not the stuff that Donald Trump hates, but it's the muscle of the artery wall. Okay. So this is actually pretty thick muscle, and this is the muscle that responds to exercise or stress levels or blood pressure. You're able to actually flex, well, not voluntarily, but your body's able to essentially flex to increase this diameter. So this is called the lumen. So this space here is called the lumen of the artery. Okay, so you've got this intima, which is the inside layer. You've got this media, and you've got the externa. I think this is the outside layer. But that's least interesting. But basically, that's very different than just a pipe. It's not just a pipe that has just one shell, and then somehow you get plaque build up like that. That's not the case at all. This is not a good model in your head for what an artery is. It will do you a disservice. And whatever teacher taught you that is doing a disservice. And whatever diagrams you've seen in biology books is also doing a disservice. It's very common, unfortunately, to show it kind of like this, and that's wrong. So what happens essentially with with plaque buildup is the following. Let's get rid of this. Let's zoom in a little bit. So here we have the artery. So we'll draw a big fat circle. Okay, so you've got the smooth muscle, which is housed between the externa and the intima. Okay, got the smooth muscle all around here. So this muscle, like I said, can flex to change the diameter of this lumen over here, to change the lumen size. Okay, what happens is, due to reasons that are complicated, and we can talk about those in a little bit, but you essentially get plaque buildup inside the media. Okay, you're not getting plaque buildup over here. Again, a lot of textbooks and a lot of videos and a lot of images online will show plaque buildup inside the lumen, and that's just wrong. Unfortunately, that's just not correct. I'm kind of surprised it's perpetuated so badly like this. This is not a correct image. This is bad. The plaque actually happens inside the muscle itself. The plaque occurs in the media. So let's get rid of that. We'll describe the process in a little bit. So what ends up happening is that over time, you get this effect where there's plaque or it's really scar tissue, essentially. This plaque is scar tissue. It's scar tissue of this muscle. Pretty strange, huh? It's very different from what you're used to thinking, oh, it's just like sort of like I eat fat, I eat McDonald's, and then somehow it just accumulates on the inside of my pipes. That's complete garbage. It's not correct at all. What happens is that there's an injury to the artery walls at some point in time. Again, not clear why that happens. There are some theories or hypotheses as to why, but it's not very clear why that happens. But some injury happens at some site here. And essentially, your body tries to create scar tissue here. But cholesterol and, excuse my dogs, cholesterol and other substances like calcium actually enter this injury site into the muscle or the media, and they start accumulating here. And so if this keeps going on and it accumulates a lot of plaque, what happens is, you can kind of tell, this slowly starts pushing the lumen inwards. So you get kind of a plaque happening all around or all inside the muscle, okay, kind of in this fashion. And this can go on for years and years and years, and the lumen size just kind of shrinks and shrinks and shrinks. And that can cause narrowing, or stenosis, it's called, of the arteries, where you don't have as much blood flow, okay? So generally, as you age, you get this. You can't really escape this very well. You just have lower blood flow. But if you notice, this doesn't kill you. There's still blood flow going on. Even though it's reduced, you might not be able to exercise very well. You might not be able to exert yourself as much, but it's not complete blockage of blood flow. So this is not what causes heart attacks. And this is not what causes strokes. This does cause kind of chronic heart disease, in the sense you have lower blood flow, you have lower performance cardiovascularly, but it doesn't actually cause a heart attack. So what does cause a heart attack? So again, let's draw a fresh artery cross section here. So here's our artery. Looks kind of weird. That's okay. So you get this interesting process sometimes where there's a lot of plaque buildup on the inside here. And then for reasons that I'm not quite clear on, and I bet a lot of people are not quite clear on, even though they might pretend like they are, this becomes an unstable plaque. So usually this is stable in the sense that it's made of cholesterol and calcium. So there's usually cholesterol, let's see, there's some calcium in there, some other stuff, basically dead white blood cells, and some other stuff that's accumulating here. But usually it's stable in the sense that it's a waxy substance. It doesn't break off. It's part of the muscle. It just looks like scar tissue. It's not so bad. What happens is sometimes that you get a an unstable plaque, it's called, where it becomes liquidy. And why it becomes liquidy, I'm not quite sure at this moment. I'm not sure we really understand. I need to investigate this more. But something happens where there's a kind of a violent inflammatory process that happens here. And this changes state into kind of a liquidy, different kind of plaque. And it ruptures through the artery wall here. This is called the endothelium, the surface over here. So it ruptures through the intima into the endothelium, through it, and then it just squirts out this unstable plaque into the bloodstream. So this is when stuff gets really dangerous. Now, you squirt some of this unstable plaque into the bloodstream. Okay, so you just you get this gunk that's now into the bloodstream. What happens is your platelets freak out. And platelets are little clotting agents, as you know, little clotting blood cells that form clots so that when you get cut, for example, they clot your blood. Well, what's happening here is that exact process just freaks out, and the platelets just store and adhere to this weird plaquey substance, and they form what we call a thrombus. So this thrombus is what sucks, okay? This thrombus is the killer, because now you've got this plug, essentially, that can travel through wide blood vessels. So let's try it over here. So you can have a thrombus moving around in a large blood vessel. Let's say it's this big. That's fine. That doesn't cause much trouble. But as you all know, blood vessels kind of branch off into smaller pieces. And at some point, it will get to a place where it's too narrow to pass through, and it will just block whatever organ that blood vessel or artery is feeding. So let's say there's a brain here. So this can travel all the way and then get lodged over here. You have a blood clot. That's as simple as it is, really. It's weird. It's just a plumbing problem. It really is just a nature's plumbing problem. And so the blood just stops here, and you can't reach the brain, and so you have a stroke. Or if this was a heart, you can just substitute this with a heart, and that's when you get a heart attack, because the heart also feeds itself. It pumps blood to itself, because otherwise how will it get the energy it needs? So that's when you get a heart attack. So it's very unfortunate. It's really just a plumbing problem that could kill us. It's as simple as that. So what does LDL/HDL/cholesterol have to do with it? We can talk about LDL and HDL and VLDL probably forever. No amount of time will do this very complicated topic justice, but here's my attempt at trying to distill this down. So, okay, so these, first of all, a lot of people call this it's so-called bad cholesterol, and HDL is so-called good, but that's nonsense, because it's not even cholesterol. This is low-density lipoprotein, LDL, and high-density lipoprotein. So what are lipoproteins? Lipoproteins are little spheres that are packages that can carry cholesterol. So HDL is a high-density lipoprotein, which means it is small. If you think about it, if you're bigger, you're lower density. And then the LDL is a bigger particle that carries stuff inside it. So what is it carrying inside? Usually it's carrying fatty acids and cholesterol. Okay, so the cholesterol is not actually LDL, or LDL is not cholesterol, but it's carried inside LDL. Okay, there's all these cholesterol molecules, and also some fatty acids are there, free fatty acids, and some other stuff that I probably don't know about, but that's not important. Same thing here. So you get cholesterol and free fatty acids over here. Okay, I don't remember if it's free fatty acids or triglycerides, which are really bound fatty acids, but that's okay. That doesn't matter for this discussion. So the reason why LDL is called a bad cholesterol is that it tends to stick to the artery wall. So again, here's our lovely cross section of the artery. So when that injury happens to the side of the artery for reasons unknown, well, maybe somewhat known, but for some reason the artery gets a tear in it or some injury, and then that's when the plaque starts forming, the scar tissue essentially. And LDL, due to the molecular chemistry of it, tends to stick to this plaque and actually become part of the plaque. And it's usually oxidized LDL and smaller LDL that's worse. So small LDL and oxidized LDL tend to stick to arterial walls more than normal LDL, quote unquote. So that's all. That's why the medical community is obsessed with lowering this number, because the higher amount you have, the more that will tend to stick when you get an injury. But if you think about it, if there's no injury, there's no sticking. So that's why the LDL causes heart disease hypothesis kind of sucks. It's actually pretty weak. The more you dig into it, the more you realize that the connection between LDL and heart disease is not straightforward at all. It's not more LDL equals more heart disease. It just simply does not make sense. We'll get back to LDL in a little bit. HDL, though, is called the good cholesterol because it's actually an active carrier away from the arteries. So LDL tends to deposit cholesterol into the arterial wall. HDL tends to carry it away. So HDL moves it away back to the liver, and LDL brings it in, kind of thing. You can think of it this way, very, very loosely. Obviously, it's a more complicated process, but the liver processes both HDL and LDL, and some people have, different genes that cause the liver to produce more LDL or more HDL or less or whatever. That's why, as well, cholesterol, quote unquote, has a big genetic component to it. Okay, so lots of stuff to talk about here, including these two. You can go online, and it's an endless pit when it comes to LDL and HDL and their ratios and what's good and what's bad. Definitely, what's clear though is that LDL is involved in heart disease. Okay, so it's not like it's completely innocent, but it's not completely the bad guy as well. One thing that I like to think about, let's clear the screen here. If you have high LDL and you expect that high LDL causes heart disease directly, okay, if it was just a simple high LDL damages arteries and that's it, you'd expect then when you do autopsies on people that died of heart attack or something similar, you'd expect them to have arterial disease everywhere, but that is usually not the case. So they usually have LDL deposits or cholesterol that comes from LDL in a certain artery that fed the heart or fed the brain, but not everywhere throughout their body. So that's kind of strange. Why would you see deposits only in one part of your body and not the rest if your LDL is high throughout your blood? So that's kind of a strange thing. So some arteries are clean, some arteries are not clean. So does LDL directly mean heart disease? I think that is a bad hypothesis. It's still a very popular hypothesis, unfortunately, but I don't think that holds much weight anymore. There's definitely people trying to reverse this thinking, but it's taking a very long time, especially since the American Heart Association. I don't know, I'm pretty biased, but I really don't like these guys. They have been a problem in educating the public on what to eat and what not to eat and whatnot regarding LDL and HDL and cholesterol and heart disease and all that. They just seem to be lagging decades in research, and they just seem to be doing bad science. So I don't really trust them anymore, which sucks. You really want to trust organizations that are dedicated to figuring out heart disease, but I don't really trust them anymore, which is unfortunate. But there are other organizations that do come up with good science and do kind of meta-analyses on older studies and whatnot. So there's still hope out there. So that's basically a very quick and perhaps unfulfilling summary about heart disease. There's a lot more to be said about it. But let's talk about what could cause, if it's not just LDL, at least, what else could be contributing to heart disease? So really you want to ask what could cause injury to the arteries. Okay, so that's really how you should rephrase the question. What causes arterial, that looks awful, injuries? Okay, that's a better question than what causes heart disease. Okay, so here are some things. High blood pressure, that's kind of makes sense, but high blood pressure tends to injure your arteries more. That's actually the most logical causative agent here, I think, from my perspective at least. So if you have very high blood pressure, your arteries are getting pounded by the blood pressure, and that could damage them over time and cause those little tears, which causes the plaque buildup, which causes the thrombus, blah, blah, blah. Okay. Another thing is high blood sugar. It's not clear exactly how that causes. A lot of people just demonize sugar. It's not really that horrible. It's not a demon. Sugar is not the root of all evil. A lot of people who are speaking against the AHA, the American Heart Association, try to blame sugar instead of cholesterol, but that's still stupid and a little closed-minded. It's not just a simple explanation again. It's not just sugar equals heart disease. But definitely it seems like glucose damages the arterial walls. So there's something to be said about that. High blood sugar tends to damage arteries, just the sugar, the glucose molecules themselves, or something called advanced glycated end products, AGEs. A cute little acronym there called AGEs. Those could cause heart disease by damaging organs, and one of the organs is your arteries. So that's one thing there. Some people even think just bacterial infections can cause damage to arterial walls, which kind of makes sense. But it's not very clear at this point. Maybe autoimmune reactions. So autoimmune, your immune system can attack your endothelial cells in your arteries, maybe. We don't know. I don't really know if that's considered even a scientific hypothesis at this point. So there's a bunch of other hypotheses, but those are pretty good ones over here. The top two here: high blood pressure, high blood sugar, and you can say even like lack of blood flow. Lack of blood flow. So basically, lack of exercise. We all know that you need to exercise, and that's one of the reasons. Just keeping your blood moving. Stagnant blood tends to cause problems. Now, I don't like that hypothesis as much either, because it's not like your blood just stops if you're sitting on the couch. It's not like it stops in its place. It's still moving. It's just not moving at a high rate. I don't know though. There seems to be some protective aspect. Well, it's proven to be the case that exercise is protective of your cardiovascular system, probably because it adapts to the momentarily higher blood pressure. It rebuilds the cell wall somehow. The muscles expand and relax, keeping them supple and resistant to injury, something of that nature. But definitely lack of exercise is is an issue. So these are probably, you know, combined with, we can put high cholesterol at the bottom of this list, or high LDL, I should say, but with a couple of question marks. It's definitely involved to some degree, and you shouldn't completely disregard the LDL hypothesis here, but it's not something that should change your world if you do have high LDL. It's not as critical as I thought it was when I first got my LDL results. It's just one of many risk factors that you should, you know, weigh against your life choices and see if it warrants freaking out about or not. Okay, let's see. So one last thing before we end here. Let's talk about just a little bit what are good values for LDL and HDL. So classically, you want LDL. So again, I think it's American Heart Association that sets a recommendation, LDL less than 120 milligrams per deciliter. And HDL, since the good cholesterol, you want it to be greater than, I think it's greater than 40 grams per deciliter, and preferably greater than 60 will be protective. They call it protective. So if you have it over 60, then it's actually helping you to a significant degree. So my LDL, just for some reference here. So this is my tests here, test results. So I have a very high LDL. So my LDL is, last time I checked, it's like 240. Yeah, I think that's right. So it's more than double the upper limit of what's considered okay. So as you'd expect, as a hypochondriac, the first time I saw this, I had a miserable time. This was very unfun, especially the doctors saying, "Oh my God, you got to do something." And I was just, you know, 24 or something, stupid young. They're like, "You should go on drugs." And I said, "Well, I don't even know what these drugs do, blah, blah, blah." However, my HDL is usually pretty good. So my HDL is 85. So that's quite a bit higher than the 60, you know, good protective threshold here. So if you think about it, the ratio is pretty good. As a matter of fact, it seems like the ratio is what's important. So if you have, you know, 120 LDL and 40 HDL, it'd be considered normal, but 120 over 40 is 3. So that ratio seems to be what's important. And so I have a similar ratio. You know, I have 240 over 85. You know, this fluctuates. Sometimes it goes down to 218. You know, I've seen it as high as 270, but this fluctuates. But this is, again, this is approximately 3. And so I have pretty good cholesterol levels. Now I know that, and I don't need to freak out. But it took me a long time to research this and figure it out. And something tells me a lot of people have kind of similar profiles like this, where their body comes up with a balance that is good, and the ratios are decent. It's just that, you know, the LDL itself might be high or whatever. So in addition, I also have pretty good blood pressure. Actually, I have very good blood pressure and very good blood sugar levels. So I am no longer worried about heart disease. Yeah, yay. Took me 2 decades, but I don't think it's something that I need to worry about constantly, but I do actively work towards keeping it in check. Some of the things that, again, are important to do if you're worried about heart disease. Very important to control your blood pressure. So BP, drop your blood pressure. Drop your blood sugar level, or blood glucose. That has to go down if you want to get better at heart disease. Look up diabetes and heart disease. Diabetics are way more likely to have heart disease because of this blood sugar problem. More exercise, obviously. And then your diet, the diet aspect becomes very interesting, and that's a whole nother video. The diet guidelines of the AHA, American Heart Association, are kind of bad. But in short, you know, eat low carbohydrate, low to medium carbohydrate load diet. It doesn't have to be zero carbohydrates because that has its own problems as well. Low to medium carbs, but definitely not high carbs. And then eat a lot of fiber. So let's put that here. Fiber is good for your heart independent of its blood sugar lowering aspects. So fiber itself is important. And then here's the kicker here. So saturated fat is actually good for your heart. So this is a very strange result if you're used to the 1980s and 1990s recommendation, which is get rid of saturated fat, it's evil. Now it turns out it's trans fat that's bad. Trans fat, that's what is very bad for you. Do not have trans fats. So what are trans fats? They're usually on the ingredients list. They're called something like hydrogenated oils. So you'll see that in stuff like peanut butter, coffee creamer, shit like that. Just kind of, it's bad. Okay, usually they taste delicious. So a lot of cookies, a lot of pastries have hydrogenated oils, like Crisco. Crisco is the classical hydrogenated oil. It tastes delicious. No one's knocking the taste, but it's really bad for you. Now, luckily, FDA finally understood from research that hydrogenated fats are bad, trans fats are bad, and so even the American Heart Association said trans fats are bad, and they decided to make it illegal. So that's really cool. You're not allowed anymore. I think you can't have more than 0.5 grams trans fats in your food. I was alive, though. I mean, I was alive and going to college in the United States. And after that, for a while, where you'd look at the label and say, what's in this? And you'd see like 4 grams of trans fats, 5 grams of trans fats. Pretty terrible. But now they're illegal to produce in high quantities, which is really good. So let's go back here. Another example here is margarine. So that was the craze for a while because it's not saturated fat, margarine. But this is hydrogenated oil as well, so this is crap. Again, the new margarine that you see on the supermarket shelves has no trans fats, it's just vegetable oils, but those have their own issues as well. So, in order to keep this less than hours and hours long, I'll stop for right now. I'll make another video if you guys like this one. But this is essentially the summary of heart disease. Hope you had fun and didn't fall asleep. Bye for now.